Hello students, welcome back. This is Oligopoly, and this time we're going to look closer into how firms compete with each other in an oligopoly market using price strategies. Okay, so the first of the models will be the Bertrand model, where product is the same, homogeneous. Each firm decide what price to put to the market based on what they expect the price is going to be for the competing firm. Yeah? So firm 1 sets according to what they expect, firm 2 will set. Market demand is still the same, P equals to 30 minus Q, but this time we set MC equals to MC3, being identical firms, equals to $3. Okay, so what do you think will be the Nash equilibrium in this situation? The Nash equilibrium is simply P equals to MC. So it's a quick answer, right? P equals to MC, P1 equals to P2 equals to 3. And why is this so? Let's take a case where firm 1 is bold enough to price its good at $5, but firm 2 says, I'm going to stick to $3. And obviously the market will move, the market share will move from firm 1 to firm 2. So there is clear incentive that to choose a price that is lower than your competitor. Okay, but the question is how much you can cut, or how much you can how far can you let the price war go. So the answer is you can reduce price, but no lower than your MC, because that will risk you operating at a loss. So that's why since they don't know what price the other firm is going to offer, they better price their goods at the lowest that they can in order to secure their position, and that lowest will usually be their MC. Okay, so let's see if price equals to 3 now. We know that price equals to MC and therefore equals to 3. For both firms, they will adopt the same price. So bring back to P equals to 30 minus Q, 3 equals to 30 minus Q, Q equals to 27. And this is the Q for the market. So Q1, since both firms are of equal size, Q1, both firms will share the total quantity equally amongst each other. So Q1 is just 27 divided by 2, and that's the same with Q2, or 13.5. All right. Okay. Now let's take another mathematical example. This is duopolies. Both have fixed cost lump sum $20. And they face their different demands, given here. So let's take the perspective of firm 1 first. Firm 1 will make profit when revenue minus cost. Okay, do you see that? P1 Q1. And P1 Q1 means they must break up P. They must break up the P1 P1 Q1, so P1 must multiply with everything in Q1 and then minus 20. So the result of that is this. Okay, and then next is to find marginal profit with respect to P1. Okay, and marginal profit, that means you differentiate the revenue profit function. So 12 and then 4P1 and P2, partial derivative. So because this is marginal profit, and to maximize profit will be to set this marginal profit equals to 0. Okay, so we solve for that, we get 4P1 equals to 12 plus P2, P1 equals to 3 plus 1 over 4 P2. And that's how we are able to obtain the reaction curve. Yeah? And you do the same, you will also get the reaction curve for firm 2. Now, what is the equilibrium? The Nash condition. The Nash equilibrium condition. The equilibrium condition will be the intersection of two reaction curves, remember? Okay, so the condition will be P1 equals to P2. So let's say I take one of them, P1, and simply replace P2 with P1. So there will be 3 over 4 P1 equals to 3. P1 will equals to 4. Okay, P1 equals to 4, and therefore P2 will equals to 4. Alright, so we know the price that they will choose. And then the profit, let's bring in all our P1 and P2 into profit for firm 1. Profit firm 1 will be 12 times 4 minus 2, 4 squared, plus 4 times 4 minus 20. If you use your calculators, you should get 12. Okay, so price for firm 1 is 4, profit firm 1 is 12. Then that's the same set for firm 2. Okay. On the graph, when you draw reaction curve, so this is the reaction curve, and the equilibrium is, as we said just now, P2 equals to 4, P1 equals to 4, and the equilibrium is here, the Nash equilibrium. That is if they don't cooperate. That's the Bertrand model. What if they cooperate? What if they collude? So we need to see, colluding means both firms agree to act as a single firm. Yeah, they conquer the market. Let's say, might as well we act as a monopoly together, and therefore the profit that they make will be shared equally in this sense. So let's say NT, or profit, total profit will be profit of firm 1 plus profit of firm 2. And I will now write again N1, from the previous page, N1, sorry about that, N1 is 12P1 minus 2P2, P1 squared plus P1 P2 minus 20. Okay, so this, since they share the total profit, so N1 will equal to N2, right? So profit of total will be simply 2 times N1, because N1 is the same as N2. So you will get, can I use this place? This space? Okay. And P1, there's no such thing as P1 and P2 now, because they are acting as one firm, so there's only one price. P1 is the same as P2, so there's only one price. But it's, the total profit is double of the profit of firm 1. So we can just double profit of firm 1. Now becomes 24P minus 4P squared plus P squared. Now P1 will be the same, so you get 2P squared minus double of 20 will be 40. Yeah, in other words, 24P minus 2P squared minus 40. Alright, so that's the profit function of this single firm. Okay, and the marginal profit from here will be 24 minus 4P. And when you set it equals to 0, P will be equals to 6. Correct? Okay, now let's try to find profit of each firm after they decided to act as a single monopoly, as a single firm. So profit 1 is going to be the same as profit 2 actually. So 12p, remember here 12p, we're looking at this one here. Okay, 12p use 6 minus 2 6 squared plus 2 times 6 times 6 minus 20. Okay, you can use your calculator and you should end up with 16. So what's the profit for a cooperative duopoly? The price 6 and profit 16. Okay, if they were not cooperating just now, do you remember what's the result? Price 4, they charge a lower price, and they're only able to obtain profit of 12. So looks like it's better to collude, if there are only two firms, so that they can charge a higher price and therefore make higher profit from themselves. Okay. Now I'm going to show you how we see aggressive competition, that they are not passively waiting for the other firm to sell, like in the first case of the Bertrand model just now, but they are neither are they colluding. What if they are still competing, but they are aggressively competing with each other? Okay, that will be the subject of the next slide, the next video. Thank you.